Hello friends, have you ever wondered what really goes into your CPU? Some registers store the final results while some others store the intermediate results which vanish quickly. So we will break down what makes the following registers so special and why are they called special purpose registers, right? So welcome to my YouTube channel. So let's start the video. So for the explanation of the special purpose registers, I have taken the example of the memory which has 1024 words, right? And I have already told in my previous video that one word is a combination of 16 bits, right? 16 bits means 2 bytes. So this is a diagram of the memory structure. Basically the entire memory has been divided into the number of blocks, and the number of blocks are these 1024. So these are 1024 um, you can say memory blocks, right? The first address is 000 up to 16 times 0, right? And the last address is 111 up to 16 times 1. And all other addresses will lie between these two. Okay. So this is the entire memory divided into number of blocks. So the very first register is the address register. Basically, it holds the memory address, right? From where the CPU wants to fetch the address or the data. So the address is loaded onto the address bus. Then from this address bus, the address register can fetch the address, and it is used when the CPU wants to read or write the data to and from the memory, right? And the address register can point to the instructions or the data. So if we talk about the size of the address register, then the size is calculated as size is equal to log with respect to base 2 and number of words. Okay, so the size would be log base 2 1024, that comes out to be 10, right? So the size of the address register would be 10 starting from 0 to 9. Okay, so this is the size of the address register, 10. Now let us move on to the data register. Basically it holds the actual data. Please note this one, actual data being transferred to or from the memory. So basically it acts as a bridge between the CPU and the memory. It holds the actual data being transferred, right? And it also called as the memory data register, MDR. And it is also used to store operands. Like if you want to add 3 and 5, then the data register can also store the operands 3 and 5, right? And if we talk about the size of the data register, then you can easily see from the diagram that how many bits is contained in one word. You can see there are total of 16 bits, right? 16 bits in one word. So the size of the data register would be 16. Okay, size would be 16, starting from 0 to 15. Okay, so this is the size of the data register, 16. Now let us move on to the accumulator. It is also a kind of special purpose register. So this kind of register is used in the arithmetic or the logical operations, right? And you also know that arithmetic and logical operations are performed inside the ALU, arithmetic logical unit, right? So basically, accumulator actively participates in the computation or the calculations of the CPU, and it is the main working register for the ALU, right? And the size of the accumulator would also be 0 to 15. Okay, 0 to 15, that means 16 size. Okay, now let us move on to the program counters. Basically what it does, it holds the address of the next instruction to be executed by the CPU, and after fetching that instruction, that next instruction, it automatically increments, right? Suppose from this diagram, uh, we have an instruction here I1. Suppose I1, we have an instruction, right? And the next instruction is I2, I2. And suppose that I1 instruction is located at 100 address, right? 1000, and the I2 instruction is located at 10001, right? So what it does, suppose I1 instruction has been executed by the CPU, right? So the CPU will jump onto the I2 instruction. So the program counter will store this address, the next address to be executed, not the previous address, right? So program counter, as you can see, it holds the address of the next instruction. This is the main point, next instruction. So the next instruction is here I is I2. So the program counter will contain this address 10001, not the address of the I1 instruction, right? So this is a purpose of the program counter. And after fetching the instruction, it automatically increments, right? Let us discuss what is instruction register. So this is the format for the instruction register. The first bit is I, which is at MSB, that is most significant bit. The second is opcode. It tells whether what kind of operation you are performing, like addition, subtraction, loading, etc. The third is operand. That is, it represents the address from where you want to fetch the address, right? So I holds only two values, 0 and 1. 0 stands for direct fetching of data and 1 stands for indirect fetching of data, right? So let's understand with the help of an example. Suppose the instruction register is in this format: 0 sub 4000. So what is happening here? 4000 is corresponding to operand, that is, it is the address. Sub is the operation, that is opcode, and 0 is corresponding to I, that means direct fetching of data. So whatever the data present at 4000 address, we can directly fetch that and give it to the accumulator. Okay. Suppose this is a 4000 address memory block, this one, right? So whatever the data is present at this memory block, we can directly fetch that data, right? Suppose instead of 0 we have 1. Suppose here it is 1 instead of 0. So what will happen here? 4000 is not the final address from where we want to fetch that data, right? First of all, we will go to the 4000. This is a 4000 memory block. There present another memory block. Suppose another address 3000, right? So then we will go to 3000 address. Suppose this is a 3000 address, this one, okay? And whatever the data present at this 3000 memory block, we can fetch that data, right? So one is representing the indirectly fetching data. So first of all, we will go to 4000, then we will go to another address which is present here. Here is 3000 is present at here. So we will go to 3000 address. So this is a 3000 address, and whatever the data is present here, you can fetch that data and give it to the accumulator. So this is the difference between the direct fetching of data and indirect fetching of data. And if we talk about the size of the instruction register, then the uh, size is 16 bits, right? 0 to 15. So operand holds 10 bits of data because it is an address. So we have already discussed this. The size of the address register is 10, right? In this example. So operand will be of 10 size. And 1, as I told, it holds only two values. So its size will be 2. So 10 plus 2 is 12. So the remaining 4 size will be given to the opcode, right? So this is the final size, 16 bits of the instruction register. Now let us discuss what is temporary register, right? So it holds the intermediate results during the operation occurring inside the ALU or the arithmetic logical unit, right? And it is an important point that it is not user accessible. User cannot access the temporary register because it is internal to the CPU or the processor. And it is also called the scratchpad registers in some of the architectures, right? And if we talk about the input registers, then it holds the data from the input devices like your mouse, keyboard, etc. until the CPU processes it, right? So it acts as a buffer between the input device and the CPU because it keeps on holding the data until the CPU fetches or the processes it. Similarly, for the output register, it holds the data to be sent to the output devices, right? And it also acts as a buffer for sending data to the peripheral or the output devices, right? So here I have explained the difference between the accumulator and the temporary register. So for explanation, I have taken an example of this addition operation, right? So we are adding value 1 and value 2 and storing the result in the this value 1 result. So in this operation, what is happening inside the CPU? The very first step is loading of value 1 into the accumulator, right? So value 1 will be loading into the accumulator. The second step is the value 2 is loading into the temporary register, right? So temporary register will be holding this value, right? And after loading all both of the values, the ALU adds both of them, accumulator and the temporary register, right? So this is the accumulator value and this is the temporary register value. ALU will add both of them and store in the accumulator, right? So this is the final result we are getting, value 1 plus value 2. And after performing this addition operation, temporary register will not be needed anymore, or it will be overwritten next time for the next operation, right? So basically you can understand that accumulator holds the initial value and the final destination value. So value 1 here is the initial value, right? And after performing the addition operation, result is the final value. So accumulator is holding the initial value, this is the initial value, and the final value, this is the result, right? And the temporary register is holding the intermediate result we are getting in this operation, right? So value 2 here is the intermediate value. So temporary register holds one more difference between accumulator and temporary register. Let's understand with the help of an example. So in accumulator, user can explicitly read from or write to, right? Suppose we are defining an instruction like this, add B. So that means what the user is performing, it is uh, adding the register B to the accumulator, right? So accumulator will become accumulator plus register B. Okay. So user can access the accumulator, but in temporary register, user cannot access that. As we have already discussed that temporary register is not user accessible, but accumulator is user accessible. User can perform some kind of operation, like here we are adding the register B into the accumulator. Okay. So the final value of the accumulator will become this one, accumulator plus register B. Okay. So that was one more difference between the temporary register and the accumulator. Hope this video will be clear to you. If you have any doubt, you can comment down below in the comment section. I will definitely try to answer that. Thank you for watching the video.